So let's see what we need to do to find this. In this case, we do know what c is from the start. The y of 0 equals 2 tells us that c equals 2. So we can start out with y of t equals 2 e to the k times t. Let's use our second value, and that's y of 1 equals 6. So 6 has to equal 2 times e to the 1 times k, or just k power. Divide by 3. That means e to the k equals 3, or k equals the natural log of 3. That's our k value. Okay. Let's take a look at our problems for this section. Starting off with the first one that says we have a population of a small town with a current population of 1,000. It's growing at a rate that is directly proportional to the population. The rate is 2.5% per year. So what are they telling us? Number one, we know from this idea of the population is 1,000 that we know that our C value at the beginning is 1,000. Directly proportional to, that statement says we're set up with something like this. The rate of change of the population has to equal some constant times the population itself is proportional to the population. In other words, P equals our constant C that we have over here times e to the kt. Okay. And since it gives us the rate, that rate is our k value. So this one starts us off with a lot of information. Of course, we'll write our k value as a decimal, which means our equation will simply be P equals the constant at the beginning of 1,000 e to the 0.025 t. Now, we can get that by just substituting that in. Oops, I'm sorry. I forgot to translate that to the differential equation. I answered the wrong question first. Okay. The formula for P is given here. The verbal statement for our differential equation would be this one. dp dt is equal to k times p, directly proportional to the population. Okay. X1, a car runs over a nail. As air leaks out of the tire, the rate of change of the air pressure inside the tire is directly proportional to the pressure. Okay? The rate of change of air pressure is directly proportional to the pressure. So if we translate that into a differential equation, this will be a dp dt equals k times p. Find K if the pressure before the puncture was 35 and after the puncture it's decreasing at this rate. Okay, so you can see from this, before the puncture we had 35 pounds of pressure. That's telling us that C equals 35. Next, it says that we are decreasing at this rate of 0.28 psi per minute. Okay. So let's go back to this one. We know that given this type of differential equation, we don't have to go back and keep solving that every time. This would be the pressure equals our initial value, the C value of 35, times E to the K T. Okay. And one thing with this that's a little bit different than the last time is the way this is given to us. As far as this is decreasing, it tells us that that is our rate. This means that dp dt is negative 0.28. Okay. And that's when we are at 35 psi at the very beginning. Okay. So back to this equation here. Negative 0.28 has to equal K times that initial pressure of 35. Divide both sides by 35, and we have our K value of negative 0.008. That's what we'll substitute in to this equation, and we'll have P equals 35 times E to the negative 0.008 times T. Okay. That is our differential equation, and you'll see Part C asked us to, oh, I guess we just did that, didn't we? It said find K. I'm jumping ahead. Find K. We found K. And then Part C is to write that equation. Okay, I think I need to read the questions before I keep answering these. Sorry about that. What will be the pressure 10 minutes after the tire is punctured? That's a time of P of 10. That would be 35 e to the negative 0.008 times 10. Just a matter of putting that in our calculator, and you can check your work. We should have 32.309 psi at that point. The next one says, the car is safe to drive as long as the pressure is at least 12 psi. How long after the puncture will the tire be safe? In other words,
congratulations to our state qualifying wrestlers, Jordan Miller, Giovanni Greco, Ryan Foster, and Ryan Imes, and best of luck to each of you in Columbus this weekend. At this time, we ask that all students and teachers come down and stand along the first floor hallways and cheer on our wrestlers as the Ross Band of Class lead the way through the parade. Thank you.
So, real quickly, you can see this is 12. We would just put that in our calculator and solve that. You can check this on your own and get 133.805 minutes.